Hello and welcome. I am Dr. Pauline Fu. In this video, I will using simulation to demonstrate central limit theorem. So let's begin with a simulation using Excel. Suppose you roll a die 4 times. So you get 4 different numbers. Maybe some numbers are the same. How do you use Excel to get random number between 1 and 6? So you type in equal right between 1, 6. Okay, this is the number I get. You roll a die 4 times. Okay, now calculate the average of these 4 numbers. Because it is random number, whenever I move the mouse, the number will be changed. Okay, so let's repeat this process for 100 times, 1,000 times. Okay, so you highlight this, repeat yourself 1,000 times. So each time you roll a die, you get 4 numbers, and then you do the average of these 4 numbers. You repeat this 1,000 times. All right, so 1,000 times is here. Okay, so column E represents the average. Okay, so I'm going to, all right, maybe leave as it is. Now you calculate the average. So remember each number in column E, each number in column E represents the average of 4 numbers. Each number represents the average of the 4 numbers. Okay, so column E is the average of each sample. Each sample has 4 numbers. Sample size is 4. So you got many average. All the numbers in column E is average. Okay. Now you do the average of average. What is the average of those 1,000 numbers? Okay. So you do this equal average. Maybe I will do it here. You do the average from E1 to E1000. And this is the number you get, okay? So this is on one hand. On another hand, you do the standard deviation of those 1,000 numbers in column E, standard deviation, okay? You can consider those are sample. Sample standard deviation is from E1 to E1000. Standard deviation. Okay. All right. So let's summarize this simulation. You roll a die 4 times, calculate the average of the 4 number you get. You repeat this experiment 1,000 times. You get the average 3.5, standard deviation 0.83. Okay. So now let's create a discrete probability distribution for rolling a die. When you roll a die, the number you see is X. The probability of the number is Px. When you roll a die, the possibility of X is 1 to 6. Okay, those are possible X value. The probability of seeing number 1 is 1 over 6. Okay, similarly, the probability of seeing different numbers is actually the same. So this table is discrete probability distribution table. Okay, we consider this is actually the population, okay, of rolling a die because it is involved all the possibilities. Now calculate the mean of this discrete probability distribution and standard deviation of this table. Okay, so first let's calculate the mean. So I'm going to use this one. Try to get where's my pencil? Type. I want to get a pencil. Draw tool. Okay. So remember the formula for the mean of discrete probability distribution is x times px, x times px, add them all, okay? That is the mu of the probability distribution, okay? Mu equal to this one. And we can realize this formula using Excel sum product because this sigma mathematics means SUM sum. And this dot means product, okay? X times px, that is the product. So we are going to use sum product function to calculate the mean of this table, discrete probability distribution table, okay? Sum product, array 1, array 2. And I got 3.5 is the mean of this discrete probability distribution, okay? Now calculate the standard deviation. The standard deviation sigma equal to x minus mu squared multiplied by probability of x, okay. Add them all, take square root. So that is the standard deviation, okay? So we need to figure out what is x minus mu here. So we create a column x minus mu, okay, equal to, this is x minus mu. Because this mu is the same for all x, I will use absolute cell reference, okay? So that is x minus mu. And I have to square it, okay? Square, okay? And then multiply by px. This is px, okay? So you do this for all the x, okay? And then you add them all, so equal sum, add them all, and then you take square root of this number. So you get this number here, standard deviation, okay? So now let me copy this into OneNote to do analysis. All right, so from Excel experiment, we get, this is our mean of the mean. We call this number, actually each number here is the mean x bar, okay? x1 bar, x2 bar, x3 bar until x1000 bar. Each number here represents a mean, and this number is the mean of mean. We call mu. Subscript x bar. okay, it is a 3.47. If you keep one decimal, it is 3.5. Okay, this is mu x bar represent sampling distribution of a sampling mean. Now, look at the population mean here. This is 3.5. That is population mean. We use mu. What can you say about this mu x bar and mu? They are equal. If you repeat this 10,000 times, they are going to be equal. So mu x bar equal to mu. Okay. Next, let's look at the standard deviation. This standard deviation represents the sampling distribution of sampling standard deviation. We use sigma, then subscript x bar. So sigma x bar equal to 0.8905. And this number is the population standard deviation. We use sigma. Sigma. Okay. Sigma equal to 1.7078. What is the relationship between these two numbers, sigma and sigma x bar? Let's find out. Okay. Remember, sample size is 4. Each time, okay, this is sample size equal to 4, n equal to 4. Okay. If you do sigma divided by square root of sample size, if you do this calculation, okay, it is equal to 1.7078 divided by square root of n. We know it is 2. Okay, so this number happened to be 0.8539. If you repeat this experiment, not 1,000 times, but 10,000 times, 100,000 of times, these two numbers would be the same. This number and this number will be the same. Okay, so we conclude, if you repeat this experiment, a large number of times, you get sigma x bar. Sigma x bar represents the standard deviation of E column, okay, equal to sigma divided by square root of n. Okay, so that is the central limit theorem refer to these two formulas. The first formula said the sampling distribution of sampling mean equal to population mean. The second formula said the sampling distribution of the standard deviation equal to population standard deviation divided by square root of sample size. In summary, what I did in this video, I started with a simulation using Excel to roll a die, calculate the average of the die, the number I see, and then I present the discrete probability distribution table, calculate the standard deviation and the mean of this table, and compare with the experiment to prove the central limit theorem. That's all for this meeting. Thanks for watching.